Welcome back to my YouTube channel. Now this is example 2 on Leibniz-Maclaurin theorem. The question is to determine the general series solution of the this equation, using Leibniz-Maclaurin theorem. Now, if I want to solve it here, so I need to identify my u here. So if I do it, the first thing to do is to solve it using Leibniz theorem of n derivative. So I can see that my u using this formula equals to unv plus un minus 1 v 1 plus n minus 1 un minus 2 v2 over 2 factorial. So I can see that let me write it out. From this first expression here, we're going to have our u to equals to y prime, then un equals to yn plus 2, my x equals to x squared plus 1, then my v, our v1 now equals to 2x, then v2 equals to just 2. From this is from this x squared plus 1 y prime. Now from xy prime now, our u equals to y prime, then un will equals to yn plus 1, v equals to x, v1 equals to 1. From this minus 4y is only, we can say our u equals to y, which is the same thing. The un will give us yn, and our v equals to minus 4, then v1 to give us 0, so we don't need v1. So you can see that the highest power of v is 2, so that's why we stop here. Now from this one, my un, using this formula, un is yn plus 2 dot our v is x squared plus 1 plus n un minus 1, so it's minus 1 from me. So if you minus 1 from here, so you have n plus 1 dot v1, that's 2x, plus n minus 1, which is minus 2. If minus 2 from here, because using this formula, if you minus 2, so that will be just n dot, what's our v2 is 2 over 2 factorial, that's 2. So we are done with this part. Let's go to this part. Plus my un in this part is yn plus 1, my v is x, plus our n, we have n, then n minus, we minus 1 from here, so we have just n dot, what's our v1, 1, plus this one is my un from this part is yn, then my v is minus 4, so everything equals to 0. This one cancel this. Now the next thing is to make x equals to 0. So if I make x equals to 0, you know that if I put x here, everything here will be 0. If I put x here, everything here will be 0. So if I put x to be 0 here, so you're going to have yn plus 2 is 0 square, it is 0, plus 1, that's 1. 1 times all this give us all this. So here we have n minus 1 yn plus yn plus, so this one will be minus yn 4 equals to 0. So we can see that we have yn plus 2. N is common. So n is common, so we're going to have, it remain n square minus n plus n minus 4. Yn is common. That's if I factorize yn out, so you're going to have this. Then if you open this bracket, you have this n square minus n. This one remain n, this one remain minus 4. So you're going to have n square, y equals to n plus 2 plus n square. This one cancel this, minus 4. yn to equals to 0. Now take this to the other side. So we have yn plus 2 equals to minus. So we have minus n squared minus 4 yn. Now, which I can rewrite as yn plus 2 equals to 4 minus n squared yn. Because if I use this minus open the bracket, so a way to verify this. Now, in this video, in my last video, I explained that as this my left hand side, we are going to have n y prime prime at this space, and this one should be y naught. So which means that in order to get that, so that what this is what I said, this to be this. So in order to get that, I need to make n equals to 0. So if n equals to 0, so you're going to have y to y prime prime. So if I put 0 here, so it will be remain 2. So if I put 0 here, it will just remain only 4. So it remain 4 multiplied by y0. But we are not going to write y0, so we're going to write this. Now the next one is to 1, because we are going to find 6 series of this. So if I put 1 here, so I have y3 equals to 3 y1 0. Now when n equals to 2, so you're going to have y4 equals to 0 y1 y2. So everything here will be 0. Now when n equals to 3, when n equals to 3, we're going to have y5 equals to minus 5 y3 not. When n equals to 4, we're going to have y6 equal to minus 12 y4 0. When n equals to 5, we're going to have y7 equals to minus 21 y5 0. So you see that we've gotten the 6 series of this. So for this one, n is 5. So if I put 5 here, so that will be 7. 5 here, that's 21. 4 minus 21, so that's 25. 4 minus 25, we have minus 21. So that's how we got all this. Now the next step is to change everything in order of y naught and y1. So this one is y naught, this one is y1, so which means this one is 0. So we are going to convert this. If we convert this, we have minus 1 minus 5 multiplied by what is y3. So you have 3 y1, so which is minus 15 y1 0. So this is minus 12. If I put y4 is 0, so you're going to have 0. Then y minus 21. If I put y5, which is minus 15 y1 0. So let's write 21 15 y1 0. So let's write it this way. Now we are to write out, the first thing is to write out our Maclaurin formula, which is this, plus x y1 0 plus x squared over 2 factorial y2 0 plus x cubed over 3 factorial. Then we have y3 0 plus x4 over 4 factorial. So we have y4 0 plus x5 over 5 factorial, y5 0 plus, and so, and this remaining 2, you can write that yourself. So if I do the input now, so I will have y0 plus x y1 0 plus x squared over 2 factorial. So you have 2 factorial 2 factorial, which is same thing as 2. Now, what is our y2? So if you come back here, y2 is 4 multiplied by y0 plus x raised to power 3 over 6. 3 factorial is the same thing as 6. We have 6. Then this side, what's our y3? This is y3. So you're going to have 3 y1 0 plus x raised to power 4 over 4 factorial, that's 24. Then we have y4 is 0. So anything multiplied by 0 is 0. Plus what is y5? So we have x raised to power 5 over 5 factorial. That is, let's write 5 factorial, or 5 times 24, multiplied by our y5 is minus 15, y1 is 0. Now here you're going to have y1 0 plus x y1 0 plus x square over, no, this here 1, this here 2, so we have 2x square y naught plus 3 here 1, then 3 here we have 2, so we have x cube over 2 y1 0. Then this is 0. Now the minus will come out, so we have minus 5 here is 1, 5 here we have 3, 5 here 1, 5 here 8, so we have 8, so we have y over 8 y1 0. Now we're going to collect like times, or we factorize. So y naught, we have 1 here, so if I factorize y naught, we have 1 here. There is y naught here, so we're going to have plus 2x squared plus others. Now plus y1, now if I factorize y1 out, so you're going to have x, this is y1, so plus x is power 3 over 2 minus x is power 5 over 8. So this is our final answer. Thank you for watching this video. Please like, subscribe and follow. Thank you guys.